The sky we look at night is just a calm appearance of a much more complex reality. Every star we see, every galaxy captured in telescope images, is just a part of what we call the observable universe. But think for a moment. What if everything we see in the universe, stars, galaxies, magnificent nebulae, are just parts of a bigger story? What if there is a place beyond this light horizon, where not only our hands but even light hasn't reached? Is there another universe out there, or perhaps infinite other universes? Are there other versions of us living in distant parts of an endless existence? Or perhaps there is nothing out there, just emptiness, silence, and an unanswered unknown. In this video, we will explore one of the greatest mysteries of the universe. Is there something beyond the observable universe? Imagine standing under a starry sky on a clear, cloudless night. The stars shine like diamonds in the darkness, and the moon, with its silver light, captivates you. With a simple telescope, you can see distant galaxies, colorful nebulae, and star clusters that take your breath away. Now imagine holding the most advanced telescope in the world, such as the James Webb Space Telescope, and peering into the depths of the universe. You see galaxies whose light has traveled billions of years to reach us. But wait a moment. Even with these amazing tools, you are only seeing a small part of the universe. This is where the concept of the observable universe comes in, and a deeper question occupies your mind. What lies beyond this light boundary we see? Is our universe just a small island in an endless ocean of space? Is it part of a larger structure? Or perhaps there are things out there we can't even imagine? This question has occupied the minds of philosophers, scientists, and even ordinary people for centuries. In this scientific journey, we are going to answer this question using the latest data, theories, and cosmological models. Let's take it step by step and uncover this great mystery together. What is the observable universe and why is it limited? To understand what lies beyond the observable universe, we first need to precisely understand what the observable universe is and why our view of the cosmos is limited. The observable universe refers to the part of the cosmos whose light has had the chance to reach us since the beginning of the universe. That is, the Big Bang, about 13.8 billion years ago. Light, the fastest thing in the universe, approximately 300,000 kilometers per second. With this in mind, you might think we can only see up to a distance of 13.8 billion light years because light could only have reached us in that time. But the story is not that simple. The universe has been expanding since the Big Bang, meaning space itself is stretching like an elastic rubber band. This expansion, first discovered by Edwin Hubble in the 1920s, means galaxies are moving away from each other, and the distance between them increases over time. Now, here's the interesting part. When light travels from a distant galaxy towards us, the space through which the light travels is also stretching. As a result, a galaxy whose light left it 13.8 billion years ago is now much farther away than 13.8 billion light years. With precise cosmological calculations, we know that the diameter of the observable universe is about 93 billion light years, meaning its radius is around 46.5 billion light years. This number is much larger than 13.8 billion light-years because the space between us and those distant points has been stretching over time. In other words, we are seeing light coming from galaxies that are now much farther away from us, but when they emitted this light, they were closer. Our view is limited for several fundamental reasons. 1. The limited speed of light. Light is the fastest thing in the universe, but its speed is still limited. If light from a very distant object has not yet reached us, we cannot see it. It's like waiting for a letter from another continent that is still on its way. 2. The expansion of the universe. The universe is expanding rapidly. In distant regions, this expansion is so fast that galaxies are moving away from us at speeds greater than the speed of light. This does not contradict the theory of special relativity because it is space itself that is expanding, not galaxies moving through space faster than light. The result, light from these regions will never reach us, just like trying to catch up with a fast-moving train by running. 3. The cosmic horizon. The boundary beyond which we can no longer see is called the cosmic horizon. This horizon is like an invisible wall that prevents us from seeing things farther away. 4. Cosmic microwave background, CMB. The farthest thing we can see is the cosmic microwave background, the light that has remained from about 380,000 years after the Big Bang, when the universe cooled enough for atoms to form and light to move freely. Before this time, the universe was like a hot, dense soup through which light could not pass. This means we cannot look beyond this light wall. In 1998, scientists discovered that the expansion of the universe not only continues but is also accelerating, meaning the rate of expansion increases moment by moment. This acceleration is due to dark energy, a mysterious force that makes up about 68% of the total mass energy of the universe. This accelerated expansion causes distant galaxies to move away from us at higher speeds, and in the future, even the galaxies we see today will disappear from view because their light can no longer reach us. Imagine you are standing in a vast, dark desert with a flashlight in your hand. The flashlight's light only illuminates a certain distance, and you can only see that range. Now, if the desert itself keeps growing bigger and bigger, the farther points that your light can't reach will remain hidden from view forever. The observable universe is the same. We only see the part of the universe whose light has reached us. Now that we understand why our view is limited, it's time to address the main question. What exists beyond this luminous sphere we are in? Scientists have proposed various theories, each taking us into a new world of possibilities. Let's explore these theories in full detail, with evidence, challenges, and multiple examples. Infinite universe, an endless cosmos. In this theory, the universe has no boundaries and continues infinitely. If you travel outward with the super-fast spacecraft, you will always encounter new galaxies, stars, and planets without reaching a boundary or wall. This universe is infinitely large and has no edge. Advanced telescopes like the James Webb Space Telescope and Hubble have seen more galaxies wherever they've looked. For instance, James Webb captured images of galaxies whose light began traveling toward us 13.5 billion years ago. There's no sign of a boundary or end. Galaxies and matter are evenly distributed in all directions. This pattern is consistent with the idea of an infinite universe. If the universe had an edge, we would expect the density of galaxies to change near that edge, but no such changes have been observed. According to Einstein's general theory of relativity, the curvature of space can take three forms: positive, like a sphere; zero, flat; or negative, like a saddle. Current data from the cosmic microwave background indicate that the curvature of the universe is nearly zero, which is compatible with an infinite or very large universe. Mathematical models based on Einstein's general relativity suggest that the universe can be infinite, provided that the curvature of space is zero or negative. If the universe is truly infinite, since the number of atoms and their possible configurations is finite, there could be duplicate versions of everything somewhere far away. This idea is statistically plausible if the number of atoms and possible configurations of those atoms is limited, e.g., 10 to the power of 80 atoms in the observable universe. In an infinite space, these configurations must repeat. This means there could be another version of you somewhere in the universe. This strange idea is known as the cosmic copy principle. For example, if the universe is infinite, there could be another Earth at a great distance, say 10 to the power of 10 to the power of 100 light years away, with another version of you who is watching this video right now. We cannot directly prove the infiniteness of the universe because we only have access to the observable universe. As our telescopes get stronger, we can only see a larger portion of the universe, but we can never definitively confirm that the universe is infinite. Infinity is philosophically and mathematically challenging. Some scientists believe that the infinite nature of the universe may not be consistent with physical principles, as concepts like the total energy or total mass of the universe would become meaningless. The multiverse, many worlds. The multiverse theory suggests that our universe might be just one of an infinite number of universes. Each universe can have different physical laws, fundamental constants, like the speed of light or the gravitational constant, and even distinct structures. These universes are like bubbles in a cosmic soup, each forming an independent universe. The idea of the multiverse originates from several different theories. 1. Cosmic inflation and bubble universes. Cosmic inflation is a theory that suggests immediately after the Big Bang, in a fraction of a second, the universe underwent an ultra-fast expansion. This expansion explains many of the features of the universe, such as its uniformity. Some physicists, like André Linde, believe that this inflation might not have stopped everywhere. In areas where inflation ceased, universes like our own were formed. But in other places, inflation continues, generating new universes. 2. Quantum mechanics and the many worlds interpretation. In quantum mechanics, particles can exist in multiple states, such as position or velocity, simultaneously until they are measured. This phenomenon is known as superposition. The many worlds interpretation, proposed by Hugh Everett in 1957, suggests that every time a quantum event occurs, such as a choice, the universe splits into two or more parallel worlds. For example, imagine tossing a coin. In our world, the coin lands on heads, but in a parallel universe, it lands on tails. This division happens with every quantum event, meaning the number of parallel worlds is infinite. 3. String theory and higher dimensions. String theory is one of the most advanced theories in physics, suggesting that fundamental particles are actually tiny vibrating strings. For mathematical consistency, the theory requires the existence of 10 or 11 dimensions, while we only experience 4 dimensions, 3 spatial plus time. The extra dimensions may be curled up at microscopic scales, but some models propose that these dimensions could house other universes. Example: imagine an ant moving on a piece of paper, thinking that the world is only 2-dimensional. However, you know there is a 3-dimensional world surrounding the paper. Perhaps we too live on a 3-dimensional brain within a higher dimensional space, and other universes reside on different brains. 4. Black holes and new universes. Some physicists like Roger Penrose and Lee Smolin have suggested that each black hole might serve as a gateway to a new universe. When matter falls into a black hole, it may reappear in a baby universe, a new universe created by the singularity. 5. The cyclic universe theory and black holes. This idea is still highly theoretical, but mathematical models suggest that it could be possible. For example, in Roger Penrose's conformal cyclic cosmology theory, each cosmic cycle could lead to a new universe through black holes. Some scientists, like Laura Mersini-Houghton, believe that unusual patterns in the cosmic microwave background, CMB, such as unexpected cold spots, might be evidence of our universe colliding with other universes during cosmic inflation. The eternal inflation model predicts the existence of bubble universes, although we can't directly observe them. Some quantum experiments, like the double-slit experiment, are compatible with the many worlds interpretation, although this interpretation remains a subject of debate. If the multiverse is real, there may be worlds where the physical laws are completely different. For example, in one world, gravity could be repulsive, or the speed of light might be different. There may even be other versions of you living in these worlds, with completely different lives. This idea is not only scientifically intriguing, but also very popular in philosophy and science fiction stories. Since these worlds are beyond our reach, we cannot test them directly. Some scientists, like Karl Popper, argue that theories that cannot be falsified, i.e., cannot be disproven through experiments, are not considered scientific. The multiverse currently falls into this category. Multiverse models are very complex and require advanced calculations that are not yet fully developed. Closed or ringed universe, a cosmos that loops back on itself. In this theory, the universe might be closed, meaning that its space-time has positive curvature, like a sphere. If you travel in a straight line, you'll eventually return to your starting point, much like walking on the surface of a sphere. If the universe's curvature is positive, like a sphere, this model would be correct. However, current data, such as Planck data, suggests that the curvature of the universe is nearly zero, though some analyses, like a 2019 paper in Nature Astronomy, have suggested that positive curvature might exist. If the universe is closed, there might be specific patterns, such as circular repetitions, in the cosmic microwave background, but these patterns have not yet been confirmed. This model gives us a finite but edgeless universe. You never reach a wall, but the universe has a limited size, and you could travel around it. Planck data and other observations suggest that the universe is probably flat, not closed. Even if the universe is closed, it might be so large that we could never travel around it and test this theory. Imagine you're walking on the Earth's surface. If you travel in a straight line, you'll eventually return to your starting point without ever reaching an edge. A closed universe could have a similar structure, but in higher dimensions. Can we see beyond the observable universe? Currently, we cannot directly see beyond the observable universe, but that doesn't mean we won't be able to in the future. So far, science cannot definitively say what exists beyond the observable universe, as our tools are limited to the cosmic horizon. However, the various theories we have explored suggest that the cosmos may be far larger, more complex, and stranger than we imagine. The infinite universe theory says that the universe continues forever, and there might be repeated versions of ourselves within it. The multiverse suggests that we live in just one of the infinite other universes, each with its own rules. The cyclic universe says the cosmos is in an eternal cycle of birth and death. The closed universe suggests the universe may be finite but without an edge, like a four-dimensional sphere. In the future, with advancements in technology and new tools, we may get more clues. Perhaps one day we will see the effects of other universes in the cosmic microwave background, or we might develop new mathematical models that confirm or reject these theories. Science is always evolving, and every new discovery opens a window to the unknown. What do you think exists beyond this luminous sphere we inhabit? An infinite cosmos? Infinite parallel worlds? An eternal cycle, or perhaps something we can't even imagine? Share your thoughts in the comments and let's discuss. If you liked this content, hit the like button and follow us for more cosmic journeys.